So we want to represent this function 8 over 1 minus 5x as a power series, and then we'll answer the other pieces to it. Let's just very quickly think about power series. So the power series is when we have the sum, as n goes from 0 to infinity, of x to the power n. And if we were to write out the terms, that would be 1 plus x squared plus and so forth. And we could figure out that sum because this is a geometric series. It converges if the absolute value of x is less than 1. And if it is, then we have a formula for the sum, and it is the first term, which is 1 over 1 minus the common ratio, and the common ratio here is x. So this power series is expressed as this function as long as we have this radius of convergence of 1, so as long as the x is between -1 and 1. So we're going to utilize this. This is kind of all we know, and so we're going to use that to express this function. So instead of x, we're going to think of this as 1 over 1 minus u. And we want to try and write this function utilizing that, and then seeing if we need to multiply by constants or things, and that'll be okay. So the expression I have is going to be 8 times 1 over 1 minus 5x, and that's essentially my u. So I can express this as a power series then if I have the sum n equaling 0 to infinity, and I'll just put this 8 as constant out in front because we know properties of summations, we can do that. And then instead of x, this would be 5x to the n. So that is our power series, and we could leave the 8 out in front, or we could move it inside of the summation, whichever is easier for us to think about. But now if we want the first 5 coefficients, basically it means what's going to be in front of the x's, and typically when we write this out we have this coefficient for this constant, and then a coefficient on the x, and then c2 is the coefficient on the x squared. So if it asks you for c0, it wants the constant. If it asks you for c1, it wants the coefficient of the x. If it asks you for c2, it wants the coefficient of the x squared term. So here, if I put in 0, I basically have something to the 0 power, which is 1 times 8. So the c0 coefficient is 8, and then the coefficient on the x term, if I put a 1 in here, I have 5x times the 8, so the coefficient is going to be 8 times 5, or 40. The coefficient, the next coefficient would be the coefficient on the x squared term, so I would have 8 times 5x, putting in a 2. So that would be 25 times 8 for the coefficient of my squared term, and that's going to be 200. And if I want the next coefficient, then that's going to be take this and put in a 3 for the n. So that's going to be 5 to the third, which is 125 times 8, and that's going to be the coefficient on my x to the third term, and that is 1000. And then finally, since it said 5 coefficients, the coefficient on my x to the fourth term, I'll go up here to put it, it's going to be 8 times 5x then to the fourth, so that would be 5 to the fourth, which is 625, times 8, and that happens to be 5000, and that's x to the fourth. So my coefficient there is 5000. Now the other thing it asks for here is the radius of convergence, and so we need to look, and typically if we had an x here, the absolute value of x has to be less than 1 for convergence. Well, we had a 5x, so the absolute value of 5x needs to be less than 1. So the absolute value of x needs to be less than 1/5. So our radius of convergence is 1/5.